as a second example of a mixture problem. How many liters of a 20% acid solution and how many liters of a 61% acid solution should be mixed together to make 80 liters of a 45% acid solution? The key thing to think about here before just digging in is how is this question different from the previous question? The previous question was how many liters of a 20% acid solution should be mixed with 80 liters of a 61% acid solution to make a 45% acid solution. Look at how many similarities there are between these two questions. There's a 20% acid solution part, there's the 61% acid solution thing, and then the final bucket, I guess, if we use that model, 45% acid solution. This number 80 liters appears in both questions. So, what's different about these two questions? The real thing to note here is that in the previous question, so it's the thing labeled previous question here, previous Q, 80 liters was the amount solution for cup number 2. In the question we're about to look at, in the new question, 80 liters is the amount of solution for the final bucket. So putting the question we're going to look at here, we'll draw this diagram, and the point now is that 80 is in the new location compared to the previous example we were looking at. 80 is now the amount solution of the bucket as opposed to the amount of solution for cup 2. Now, all the numbers that we were provided in the question have been placed somewhere inside this diagram. So now what do? Well, we don't know the amount of solution for cup 1 or the amount of solution for cup 2, so there's these two question marks here. Here's an interactive question. If we don't know the amount of solution for cup 1 and we don't know the amount of solution for cup 2, can we just write the same variable in both places in our diagram? What would this mean? It would be much safer to use one variable, let's say x, for the amount of solution for cup 1 and use the variable y as the amount of solution for cup 2. Then we can apply the concentration equation to cup 1. So x times 0.20, that's where this that's where this 0.20 times x comes from. For cup 2, apply the equation again, and we'll have 0.61 times y as the amount acid. And then same deal for the bucket. At the bottom, we've got 80 times 0.45. We multiply those two things together, and we'll have the amount acid for the bucket. The other thing to note here, though, is that the amount of acid in the bucket can be obtained another way. Right? We can add the amount of acid from cup 1 and the amount of acid from cup 2 to get the amount of acid in the bucket. So notice now we have two different looking ways to write the amount of acid for the bucket, and so we should set these two equal. There's one other aspect that we have done in another question already and in the exploration that we haven't really brought in yet, and that's that the amount of solution from cup 1 plus the amount of solution from cup 2 should equal the amount of solution in the bucket. So we get another equation here. We get x plus y equals 80. In the end, we have these two equations. I find it a little easier to work with the smaller equation. I'm going to solve for y. That's just the choice I made here. There's other ways to do this. So I have y is equal to 80 minus x, and I'm going to substitute in the first equation, I'm going to substitute the y that I see with 80 minus x. I will distribute then 0.61. So now we have 0.20x plus 0.61 times 80 minus 0.61x equals 80 times 0.45. Trying to organize all the terms that have x on one side and all the terms that don't have x on the other side, we need to subtract 0.61 times 80 on both sides. Now that both terms on the left side have an x, I'd like to factor out x on the left side, do nothing to the right side. And now that the left side is really a number, it's a bunch of stuff all in parentheses, but that's a number times x, let's divide by that number on both sides. So we have x equals this fraction. The numerator is 80 times 0.45 minus 0.61 times 80. This is all divided by this denominator, which is 0.20 minus 0.61. We can actually also recall that we earlier said y equals 80 minus x. In fact, it's the second line of the slide. And so we can plug in this numerical value of x that we know. We have 80 minus and then replacing x with the fraction. Now we have a numerical value for y as well. So then we can answer the original question. The original question said something like how many liters of the 20% acid solution and how many liters of a 61% acid solution should we use? So there's really two questions there. We need this number that we saw earlier as x, liters of the 20% acid solution, and we need 80 minus that fraction, liters of the 61% acid solution.